Please click our subscribe button and our notification bell to receive notifications on our latest uploads. Thank you. Hi kids! Welcome to our Mathematics 4 class. I am your teacher, Teacher Zaida. Our topic for today is finding the greatest common factor or GCF of two numbers using prime factorization method. Let's define greatest common factor or GCF. So when we say greatest common factor or GCF, this is the biggest among all the common factors of two numbers. Again, GCF is the biggest among all the common factors of two numbers. Okay, before we continue, let's have a quick review. Prime numbers are numbers with only two factors. And those two factors are 1 and itself. Again, when we say prime numbers, these are numbers with only two factors. And those two factors are 1 and itself. So for example, 2 is a prime number because it has only two factors, 1 and itself. Same as the number 3, 5, 7, 11, 13. These are some examples of prime numbers. There are three methods in finding the GCF of two numbers. First is the listing method. Second, the prime factorization method. And third is the continuous division method. To use prime factorization method, let's define prime factorization. When we say prime factorization, it means expressing a number as a product of prime numbers or factors. It can be helped with the use of a factor tree. Okay, let's try finding the GCF of 8 and 12 using prime factorization method. Now, since this is a factor tree, we now put our branches. And think of two numbers that when multiplied, we get 8. Okay, yes, very good. We could use 2 times 4. Is 2 a prime number? Okay, yes, very good. Since 2 is a prime number, we stop at 2. Is 4 a prime number? Okay, very good. 4 is a composite number, so we still put branches under 4. And think of two numbers that when multiplied, we get 4. Okay, very good. We use 2 times 2. Now, since we know that 2 is a prime number, we stop here. So the prime factors of 8 are 2 times 2 times 2. Did you get that? Okay, very good. Now let's do 12. Let's put our branches under 12 and think of numbers that when multiplied, we get 12. Okay, yes, very good. 3 times 4. What? Can we use 2 times 6? 2 times 6. Yes, we could use 2 times 6 because 2 times 6 is 12. Okay, let's use 2 times 6. Now, since 2 is a prime number, we stop at 2. Is 6 a prime number? Okay, very good. 6 is a composite number, so we put branches under 6. And think of numbers that when multiplied, we get 6. Okay, yes. 2 times 3. We stop at 2 because 2 is already a prime number. How about 3? Okay, very good. 3 is also a prime number, so we also stop here. So the prime factors of 12 are 2 times 2 times 3. Okay, let's now compare the prime factors of 8 and 12. So again, prime factors of 8 are 2 times 2 times 2. And then for 12, we have 2 times 2 times 3. And then we take the common prime factors of 8 and 2. We have 2 and 2. And then we multiply these common prime factors. 2 times 2 is 4. So the GCF of 8 and 12 is 4. Did you get that? Okay, let's have another example. Find the GCF of 15 and 20. So the first two branches of 15 in our factor tree, we think of two numbers that we could multiply to get 15. Okay, we could use 3 times 5. Now, is 3 a prime number? Okay, yes, very good. So since 3 is a prime number, we stop here. How about 5? Okay, good job. 5 is also a prime number, so we stop here. So the prime factors of 15, we have 3 times 5. Questions? Okay, let's try 20. First two branches of 20, we could use 4 times 5 because 4 times 5 is 20. We could also use 2 times 10. Now we know that 2 is a prime number, so we stop here. And then we put 2 branches under 10 and think of two numbers that we could multiply to get 10. Okay, good job. We could multiply 2 times 5. Now 2 is already a prime number, so we stop here. 5 is a prime number, so we also stop here. So the prime factors of 20, we have 2 times 2 times 5. Did you get that? Okay. Okay, let's compare the prime factors of 15 and 20. So for 15, we have 3 times 5. And for 20, we have 2 times 2 times 5. Now to get the greatest common factor, let's look for common prime factors of 15 and 20. Is there any common prime factor? Okay, yes, good job. The only common prime factor is 5. So therefore, the GCF of 15 and 20 is 5. Okay, it's time to do some exercises on your own. Let's find the GCF of the following using prime factorization method. Okay, number 1, we have 16 and 24. Number 2, it's 20 and 30. Number 3, it's 36 and 45. Number 4, 28 and 42. And for number 5, 32 and 40. So just pause this video lesson until you're done from numbers 1 to 5. And then just play this again so we could check. Okay? Are you done? Okay, let's check. Answer for number 1, we have 8. Very good. For number 2, answer is, okay, yes, good job. It's 10. For number 3, answer is 9. For number 4, okay, very good. Answer is 14. And for number 5, answer is, okay, it's 8. Very good work today, kids. I think you are all ready for your module. You can do it. Until next time, goodbye.